All right, starting with number one. This is considered the differential equation given by dy over dx equals xy over 2. Sketch the slope field through the indicated points. Yes. So through each ordered pair, we can identify the location of that ordered pair and start inserting into the differential equation. So in this case, 0, 0, and for x and y, we get 0 over 2, that's 0. So you're going to put a horizontal line to indicate at the 0 slope through that point. Zero, 1, same thing. 0, 2, 0, 3. 1, 0, also 0. 1, 1 will give me 1/2 positive slope. 1, 2, 2 over 2 will give me positive slope. 1, 3, 3 over 2, positive slope. -1, 0. -1 in for x, 0 in for y. 0 over 2 is 0. -1, 1, -1/2. I get -1. Then -3/2. Okay, it says find the particular solution for the differential equation. So we're going to cross multiply and go through all that process to separate the variables. So we want y's on the left, x's on the right. But a couple of things are out of place. Can you identify those? Yeah, y needs to be divided. What else? The 2. Now it's not wrong to put to leave the 2 here, but eventually we have to move it to the right side anyway. So let's go ahead and move it over as well. So we're going to do a double division here. Divide by y to the left and divide by 2 to the right. Okay, does everybody follow that? Okay, so we have full separation. Y is on the left, x is on the right. Natural log rule on the left, power rule on the right. Yeah.
How come the 2 can't just remain there? How can you divide?
Eventually we have to solve for y, so you can leave the 2 here, but eventually you can move the 2 over to the right. I just like to just do as much cleanup as I can as I move along, but if you leave the 2 there, it's fine, but at the end you're gonna move it over anyways. Okay, left side is natural log. Natural log has the value of y. 1/2 x becomes 1/2 power rule. Raise both sides. E is the base. Because I want to solve for y. want to separate that C away from my variables. Okay, drop the absolute, well, I can turn this into a C, pull that out as a coefficient, drop the absolute value. Right, so now I've cleaned this up enough where I'm going to go ahead and plug in my ordered pair, solve for C. One in for X, one in for Y. Okay, divide by E to the 1/4 to solve for C. So now just put this in place of my C value to get my specific solution. So this is fine. You can leave it in this form. Or you could bring that E up to the top, change the sign of the exponent, and then merge those together. So that E can come up as E to the negative 1/4. X squared over 4 minus 1/4, they already share a common denominator, so I just put it all as one fraction. But this want to show you a cleaner version, but you can leave it in this form, is fine. All right, part C, it says write the equation of the tangent line. So this is the clue here. Tangent line is linear, right? So y minus y1 equals m times x minus x1. So let's create our tangent line equation. We need ordered pair and we need slope. Slope comes from your derivative equation. Slope is 1/2. Tangent line equation. So now that I have my tangent line equation, I can insert the 1.2 in for x to get the linear approximation. You can leave it unsimplified, or you can use your calculator and get it down to a decimal value. Okay, any questions? Number one. All right, I'm going to skip number 2 for now. This is good for solving differential equations, but your word problem is going to be feel more like y equals c e to the kt rather than this. But this is still good practice for solving differential equations. But we already did one of those above. We'll come back to this if we have time. Okay. Okay, matching slope field. When we're trying to match slope field, there's 4 categories that we like to look for, because there's only certain things we can tell. We don't know exactly what the slopes of these values are. We can tell a positive slope from a negative slope, but we don't know whether it's a slope 1/2 or slope 3 or slope 5/2, and we're not expected to. Yep.
Oh.
There's additional notes. Slope fields.
Thank you.
Okay, page 16. I match slope field with the correct equation. So we like to look for 4 things here: positive slope, negative slope, slope 0, and slope undefined. Sometimes we're not able to tell what's happening along the X and Y axis, because you can tell that it looks like it's either nothing here or it's a slope 0. So we really have to kind of rely on something else. Here, we don't know whether that's slope undefined or whether these are tick marks. That's showing. I think this is more like showing that those are the tick marks. And then here, this is either hiding a slope 0 or slope undefined. But what we can tell are the quadrants, right? The quadrants are showing very specific behaviors here. So it looks like everything here is showing me what slopes does it look like here. Quadrant 1 is positive slope. How about quadrant 2? Negative. Quadrant 3 and quadrant 4.
Negative.
Negative. Okay. So I think from this, we should be able to narrow down which ones are not correct, right? Because is this going to give me a positive value in quadrant 1? No, right? If I plug in 1, 1, for instance, right, that looks like a positive slope to me. I'm getting a negative, so I can eliminate A and B. So it looks like it's probably C. And then here, if I look at D here, is this going to give me, if I plug in 1, 1, for instance, what's going to happen here? Undefined, right? I get a 0 in the denominator. I don't see any undefined here. I don't see any empty gaps at 1, 1. So this is pretty straightforward. And sometimes you might not be able to quite narrow it down all the way to just one choice. If it doesn't, then I would pick off specific order pairs, plug in, and convince yourself that it actually, you may not know exactly if it's like it's 1 versus 3 halves, you're not going to be able to know. But if one option gives you 1 and the other gives you a negative, you know the negative must be out. So you can just kind of go through each quadrant and just test, especially if you're down to 2 and you've labeled all your major properties. You're not seeing that. All right, so part B says find a particular solution. So we know we're starting with this, so we'll find the particular solution. Cross multiply. So once I cross multiply, it looks like it's already giving me separation of variables. Y is together, X together. So I can just go ahead and take the antiderivative. Now, if you want to solve for C at this point, you're more than welcome to. I just want to clean up a little bit here, multiply through by 2 here, just to get that left side a little bit easier. Me to solve for C. So it feels a little bit easier now for me to plug in my ordered pair. That's just my preference. So now that I have my C value, I'm going to insert this back into where I started making my substitution. Plus or minus comes out of this. Square root. Which one do I choose between the plus or minus square root? Because y is negative. Okay. Now, I'm not so worried about finding the domain. Not see that, not see that on the test, but it says to sketch a solution through the given point. So the given point is 5, -2. So we're just going to follow the pattern of the graph and see what that graph looks like. Now, what do we know about this y equals 0? Now that we have differential equation. Slope is what? At y equals 0, slope is undefined. Okay. So what's going to happen is as we sketch the graph and we're going towards a place that slope is undefined, that's going to basically be a wall. Okay, so the graph is not going to go past that point. It's not going to skip over that wall and continue the path. So as soon as it hits a wall or a place that's undefined, you're going to make the graph stop. But you're just following wherever the graph leads you, that's wherever it goes. But just remember that if you hit a place where the graph is undefined, you're going to go to that point and you're just going to stop. You're not going to continue that graph past that point. Okay, we won't worry about the domain right now. Okay, any questions there? So you identify the order pair, plot that, and then from there you just follow the stream of the graph. All right, let's look at number 4. All right, fairly complex here. What does this look like to you? The U sub, right? What could be a good guess as to what the U value could be? All right, we see a denominator, we see a parentheses. So that's usually a good place to begin making our guess. So our U value is just that a portion inside the parentheses. It's more like a 5255 quiz review problem. Right, what's e to the u's derivative? E to the u times u prime. So this is e to the negative x times what? 1. Right, cross multiply. Make your substitutions. Parentheses gets replaced with u. Dx gets replaced with du over e to the x minus e to the negative x. So after I make my substitutions, it looks like I do need to get the e to the x to go away. Otherwise, I'm not able to get full u substitution to work out here. But do I have a perfect match right now? It's close, but it's not perfect. So what could I do to make it so that I can get a perfect match? Factor 2 out. Okay. So this we can reduce, okay? Before, right, we can't just pick and choose and cancel out, right? We can't cancel across addition and subtraction. We gotta wait till we get a perfect match. Now we can take those, go away. Okay, so what does this look like to you here? What rule? Is this a natural log rule? We gotta bring that u up and go through what? Power rule, right? We can only do, I know the temptation is you want to do natural log, you see the u in the denominator, but natural log only works if it's u in the denominator and raised to what power? 1, right? Any other power, you got to bring it up and go through power rule. There's my antiderivative. I'm just going to do some cleanup here and then replace the u back in terms of x. Okay, number 5. Okay, look at how this is set up here. It really helps if you're able to kind of predict what rule that we're trying to work towards. What rule could be the best fit down the road? Because it's obviously u substitution, but if we can kind of see the big picture, then it kind of helps us identify what the u value could be. See that 3 there, right? That's a base raised to a variable. This is an exponential function. This is a to the u. So this is the rule that we're trying to work towards. And if we can kind of see the end result, then we can have an idea what our u value, right? What's our u value? Cosine, right? In order to get that fit, right? That a being 3, that u being cosine x. And this should work out pretty nice because what's cosine's derivative? Negative sine. So even if the negative didn't cancel out, it will still be a good fit, right? But in this case, the negative and the trig function will pair up nicely because of this derivative here. All right, perfect match. I'm left with a to the u, or in this case, 3 to the u du. Now I can apply my rule. My a is 3. So there's my antiderivative. There's my answer. My only adjustment that I need to still make is replace the u back in terms of my original variable. If you want, you can put the natural log of 3 below this value, this a to the u, or I can leave it outside. It's up to you. And number 6 is more complicated than what you need to be able to do for completing the square. So let me revise number 6 here. Okay, so by looking at this, we know that this is going to be an arc trig because you look at that degree gap, right? There's degree 2 in the denominator, there's a degree 0 in the denominator. There's a gap of a 2 or more. So in this case, that gap tells us arc trig is probably the best fit. And then amongst our arc trig rules, there's 2 that has a square root and there's one that does not have a square root. So we know arctangent will be the better fit for this one here. Right, but before we can get into this form, we have to do a little bit of cleanup or a rewriting so that we can get our a and u value a little bit easier for us to identify, because right now it's hard to see what the a and u value are. We have to complete the square. And what goes into space is b over 2 squared. Okay, what's my b value? -2. 2 over 2 is 1. 1 squared is 1. So those 3 terms should now factor nicely here. Multiplies to be 1, adds to be -2, -1 and -1. And then put the constants together. All right, so x minus 1, we want to get it into the form of a squared and u squared, or parentheses squared and parentheses squared. So this should be easy, right? X minus 1 squared, so that can go here. And how can I rewrite this 9? 9 is the same thing as what? 3 squared, right? So the whole purpose of us doing this is so that we can look inside these parentheses and then we can pick out our a and u value correctly. Because if we're just looking at this, we may be mistakenly thinking that our a value is 9, but our a value is actually 3. Going through my substitution, I'm trying to make my problem look like this rule so I can apply it. I'm able to get a perfect match because I can push that -8 out in front. Now I'm ready to jump into my rule. Okay, so -8 comes first. Over here. Times 1 over a. My a value is 3. U over a. Let's see. Cosecant U, this is one of our newer rules. But we have to go through a little bit of what? Substitution, right? Anything that's more than an x, whether it's 5x or 1/2 x or right, anything we have to go through use substitution. We can't just jump into the rule. Right. No x to cancel out, but we have to keep track of this -3, so it comes out as what? -1/3. Perfect match. Let's apply our rule. Two negatives become positive, and then bring our x variable back. Okay, let me squeeze in one more problem if we can find any room. Okay, any idea what could be a good fit for this problem? Yeah, synthetic, right? So we know it's not power rule because it's more than one term. And use substitution is probably not going to be a good fit. And then, however, if the degree in the denominator or numerator is the same or higher in the numerator, then that's a good fit for synthetic or long division. We can't do long division. We can't do synthetic division unless the denominator is degree 1. So this does fit that bill. We can do that. Let me rewrite this problem, though. Maybe this is easier to work with so that we can get that numerator. We want that degree to be decreasing here. So we start off by setting our denominator equal to 0. This will be a short synthetic division here. -3 for my degree 1, 4 for my constant. Right, what's my first step here? Okay, bring that -3 down, right? Don't multiply this by 3 here, just bring that down. Now we can do what? Multiply. Add. So we start off with 3x here, so this is going to become a constant, and this is going to be the remainder. We have to put this over x minus 3. Now, we haven't solved the problem yet, but we've created an easier problem to work with, so now this is all we have. Okay, so this term we can handle using power rule, and this we got to go through a little bit of use substitution, but it's going to end up being a what? Yeah, 1 over u, natural log, right? Okay. Okay, so -3 becomes -3x. -5 natural log of u. Replace the u back in terms of x. See. All right, we'll continue reviewing in class. Let me know if you have any questions. Yeah, consistent.
Oh, gosh, the back. dx equals 1. Thank you, Mr. Yang. Have a good day.
Because I have to do something. I'm trying to get everything in terms of u of a.
Yeah.
So my derivative of u is x becomes 1, 1 becomes 0. So x equals 1. I saw for dx equals u, so I replace that dx with u. But I'm trying to get everything in terms of u, I can get my match.
So there's an invisible.
Yes, there you're right, exactly.
Look, this bakery has turtle bread. So I want to say, I don't know, some girl that I don't know, it's.
Same thing.
So I'm undergrounded. Yeah, I'm grounded into snack. I got grounded for 7 days and not closing the garage door. I thought it was just the weekend. No. But it's like, I mean, yeah, it's like, except like, you know, Canadian short of mine.
The only additional ones that we should learn, pass the quiz.
Invited me every night. I'm like, I'm so. Oh, yeah, I really kind of wanted to go, but like, I think you're going to so much. Yeah, I need to go eventually. I know.
So I could.
It's like.
Yeah.
I wish me and
Get caught up.
I'm calling.
All this. Huh?
You guys just, yes.
Yes, we did, reviews like she.
Like, it's like not.
Huh? Yes, I have to put on wisdom.
Yeah.
Yep.
This is God.
Oh, yeah, you can.
Uh-huh.
To be so honest with you.
Yeah.